Welcome to Spring LIB.
Here, initial speed of bicyclist equals to 12 km per hour, which can be written as 3.33 meter per second. And we have speed used by bicyclist to descend equals to 32 km per hour, which can be written as 8.89 meter per second. Now, here the net force acting on the bicyclist initially is given by m multiplied by g multiplied by sine theta equals to f of fr. We can consider this as equation number first. Here m is the mass of the bicyclist, g is the gravitational acceleration, theta is the angle of the hill. Now the given equation for the frictional force is given by f of fr equals to b multiplied by v square. Now we can consider this as equation number second or 2. Now on equating the above two equations, we get m multiplied by g multiplied by sine theta equals to b multiplied by v square. Now on rearranging the above equation for b, we get b equals to m multiplied by g multiplied by sine theta divided by v square. Now here on substituting the value, we get b equals to 75 multiplied by 9.81 multiplied by sine 4 degree divided by 3.33 whole square. Now on simplifying, we get b equals to 4.62 kilogram second per meter. Now here the power dissipated by the frictional force is given by P equals to F of Fr multiplied by V. So we can write this as P equals to B multiplied by V square multiplied by V. So we get power, that is P equals to B multiplied by V to the power 3. Now here on substituting the value, we get P equals to 4.62 multiplied by 8.89 to the power 3. So we get P equals to 3245.99 watt. Now the power due to the gravitational force is given by P of G equals to m multiplied by g multiplied by sine theta multiplied by v. Now here on substituting the value, we get P of G equals to 75 multiplied by 9.81 multiplied by sine 4 degree multiplied by 8.89. So now on simplifying, we get P of G equals to 456.22 watt. Now here the net power used by the bicyclist to descend is given by P dash equals to P minus P of G. Now on substituting, we get P dash equals to 3245.99 minus 456.22 watt. So now from above we get P dash equals to 2789.77 watt. Now here the above same power is used by the bicyclist to climb that hill. While the bicyclist climbing the hill, the force due to gravity and the frictional force will be on the same direction, that is towards the downside of the hill. So the power due to the gravity force and frictional force will be added. That is P dash equals to P of Fr plus P of G. We can consider this as equation number third, or we can say 3. Now here we can write this as P of dash equals to F of Fr multiplied by V plus M multiplied by G multiplied by sine 4 degree multiplied by V. Now here we can write this as P dash equals to B multiplied by V square multiplied by V plus M multiplied by G multiplied by sine 4 degree multiplied by V. Now on substituting the value, we get 2789.77 equals to 4.62 multiplied by V to the power 3 plus 75 multiplied by 9.81 multiplied by 0.06975 multiplied by V. Now on simplifying this and then rearranging this in terms of V, we get V equals to 8.0146 meter per second, or we can write this as 28.85 kilometer per hour. Therefore, the speed of the cyclist to climb the same hill equals to 8.0146 meter per second or 28.85 kilometer per hour.